We're going to get started with a brief introduction from Mike Gibaldi of the Surfrider Foundation Miami. Here you go. Oh, of course. Go for it.
That'll be
Yeah,
Jim.
no problem.
He is right here. Yeah.
Yeah.
Perfect. All right. Good afternoon. Courtesy of Spikefish Data Solutions that did a sponsorship of the conference, Christy LeMahieu decided to let Surfrider have a couple moments of comment first. So good afternoon, everybody. I've been a volunteer leader with Surfrider Foundation for over 20 years. You can find me at the beach 2 to 4 times a week, every week of the year that I'm in town. Winter, summer, whatever, I'm in the water on the beach. Surfrider can be boiled down to very short statement: clean water and healthy beaches. A lot of what we're talking about here today. So while our activities focus on oceans, waves, and beaches, wherever you live in Miami-Dade County, you, your family, your companies, your local governments, activities impact our coastal waters. You could be in deep West Kendall and there's a storm drain in your neighborhood. That storm drain goes to a canal, goes to a bigger canal, to the Miami River, to Biscayne Bay, to the beach where my daughters and I swim and where you all recreate as well. So it all connects to our local beaches. The ocean needs more friends. How you can get involved with Surfrider: become a member. We're going to flash a QR code here. I'll be carrying it around. Very low entry point to become a Surfrider member. We need your voice. We need your vote when things are happening in Tallahassee and local governments as well. But some of the things you can do: Blue Water Task Force is our premier water quality testing and reporting campaign or program within Surfrider. You're going to hear more about that today as part of the data and water quality. Dune restorations, Rise Above Plastics. Our SEAS program is teaching inner city. We don't deal with kitties yet. That was for the Brady Hunter Foundation. Inner city kids how to swim that don't even know how to swim, and then introducing them to the ocean and coastal conservation, just the whole idea that it all connects wherever you live. Compost, we have a composting program with a City of Miami Beach grant. Ocean-friendly restaurants. And again, legislative alerts is another way you can get involved. So thank you and see you at the beach. I'd like to introduce our first panelist in this session, Dr. Forkerin. I call him Jim now because we're chatting about, we're both EV drivers beforehand. Distinguished University Professor of Biological Sciences and Director of the Coastlines and Oceans Division of the Institute of Environment at Florida International University. Yeah. So FIU efforts are to increase Biscayne Bay data transparency and accessibility for Biscayne Bay. Dr. Forkerin, it's all yours.
And thanks for everything you guys do. We need clean beaches, because without clean beaches, people stop coming to Miami, I'm sure. So the cautionary tale: don't let your graduate students sign you up to go to meetings and not pay attention, or you find yourself where I was on Friday saying, "You did what?" So I'm here. Is Laura in the room? Oh, look for Laura Reynolds and blame it on her. Laura felt it was really important for me to let the community know that there are lots of ongoing efforts to try to bring together all of these fabulous data that are being generated by county government, by private foundations, by universities, by the federal government. And these data are, there's a rather high bar to accessibility and the ability to interpret these data that has to be crossed before they're applicable in management. And we got some money from FDEP in the last Biscayne Bay and Reef Tract funding cycle to try to start to bring together a system that will allow us. BROIPS is the Biscayne Bay and Reef Observation, Interpretation, Prediction System. The idea that we'll get all the data together, write the AI interfaces that will allow it they'll allow us to do these analyses very easily. So which one is the? So we want to facilitate management by making data access easier. We're after digitizing historical data sets, recognizing and valuing long-term data sets and giving them a common platform so they can be discovered, basically by using geographic search terms. So you could actually know if there were dolphin sightings near your seagrasses, near water quality, you know, these various components and disciplines that often don't speak to each other. And that's among the scientists, and then the managers have to take it a whole nother level, and the politicians even more. So we're trying to search and find all the data buoys that exist, all the USGS data, the NOAA data, the county data, and bring them all together into a common framework. So our study area is basically Biscayne Bay and the reef. And we understand that there are, because it's the bay, in order to understand what's going on in the bay, we have to understand the watershed. And the watershed is represented by these canal sheds. That's bringing materials into the bay and bringing organisms into the bay. But we want to take that idea of watersheds bigger, and we're calling this our data shed, because data that's collected actually everywhere south of Lake Okeechobee and north of Lake Okeechobee as well, but we needed to limit us somewhere. These data are important. They're important weather data. They're important climate data. They're important all kinds of data that are equally important for understanding what's going on in Biscayne Bay. So in this data collection effort, we're reaching out basically to all the South Florida Water Management District area. So all the data sets we're trying to collect are from that large area. We're interested in legacy data sets. For instance, does this pointer work? Yes, but it doesn't work. No, no, it doesn't work. So I showed these earlier today. This was a benthic vegetation map made in 1925. It's really hard to find this. In fact, the only place I know where I can find it is a Biscayne National Park report. This was the 1976 vegetation map. There's a lot of really interesting data in there. This is the finest Biscayne Bay map that's ever been made. Is Gary Milano here? Has anybody seen him? Gary Milano swam every square inch of the bay and his team for Durham, and put these maps together in the later 70s, early 80s. So these are really important legacy data sets, and I'm just concentrating on the seagrass ones. Broips is much larger than seagrass, but I'm a seagrass guy, so that's what you're seeing in this talk. We're also trying to bring together all of the possible ongoing data sets we can find. The low-hanging fruit is all of these telemeter data sondes that are all over the place. And every time you talk to a group, you find somebody else is putting out yet another telemetered sonde. And you know, in order to use those things, you have to have a centralized place where you can see the metadata, see the calibration data, use a common language to address the things that are in the data. So we're bringing all of, say, the sonde data together. And we're using basically a geographic shell called Terrafly that allows us to query data in a geographic and a temporal sense. And then that part's already done. What we're working on now is to figure out then how to do the visualization tools, the interpretation and visualization tools. We're using this process to also identify data gaps. For instance, these are seagrass data. These are nitrogen to phosphorus ratios. These are the data we need to know is if you pollute it with nitrogen or phosphorus, which one's going to matter. And, you know, the whole central part of the bay basically is data deficient. So we're going through this process, identifying data gaps in all the various environmental data sets we're trying to bring together. We're asking questions like, all right, we know that there's a big data buoy network, but we know there are holes. And we had first workshop on this, and we got pretty general agreement that basically the pressure valve is where all the water mixes and there's no longer any data being collected there. So we're putting a new buoy out there that'll be available as soon as the Army Corps gives me my permit to put it back out. So we've done these things. We've addressed them in a series of workshops. Oops, wrong one. And why? Because we're trying to find the data gaps. We're trying to communicate the current data. We're trying to facilitate effective management through accessibility. We're trying to empower the community of scientists, advocates, and managers to actually know where all the data are. And we're trying to create this data management plan for the entire system. So we've had a couple of workshops already. We're going to have more workshops. We are looking to collect data from all of you data providers. And we've got some standard forms. I'm sorry that somehow I erased the QR code on here. But please, if you've got data you would like to contribute to this, please, please, please stop me and I'll give you all the information so that you can get your data in. We're trying to properly mark all the data, of course, so that attribution is made to the people that collected it. You're not giving your data away to you're basically giving it to a library that will tell everybody where the data comes from. All right. And I think that I'm going to get us back on time. Indeed, I did. So thank you. It's no data itself, just talking about data. Yes. The first buoys we put out, I paid about $140,000 each for them, and they all were destroyed by boats running into them in the first month and a half. So we're now just spent a whole bunch of money armoring the buoys so that it'll hurt the boat instead of hurting our buoy. And luckily there's a nice guy down, a nice engineer down in Cutler Bay who loves making stuff like this for us. But they're everything from $5,000 water quality sondes that people have reporting data into this network to these more oceanographic. It's because we've got pH and PCO2 and imaging sonar and ADCP. So the buoys that we're putting in are really, really complicated ones. But a lot of the people that are reporting data are reporting 2 or 3 or 4 parameters, and that's it. So they can cost way different amounts. And we're also interested, of course, in the grab sample data that's being collected. There's a tremendous wealth of grab sample data that's still being used in management today. But, if you don't know that Henry Biscayne took the program over from Joe Boyer and you can get the data from Henry, you would not ever know how to even get it. So we're trying to make it all available. Okay, thanks.
Hold your questions for now, guys. We're going to try and get through all of the presentations for the session, and then we'll have some time for questions at the end before the next talk. All right. Next, I'm welcoming up Christy LeMahieu of the Blue Water Task Force Lab and Director of Surfrider Foundation Miami chapter. I think we have the pointer. All right.
Thank you.
And the pointer reflects off the screen. I think you have to be right in front of it.
Okay. Good afternoon. Hi, my name is Christy LeMahieu. I am the current lab director for Surfrider Miami Blue Water Task Force. I also am the CEO and owner of Spikefish Solutions, which is a IT company specializing in data analytics, cybersecurity, and automation. So what I am not a scientist. My specialty is data. So when I became the lab director for Blue Water Task Force Miami, my first question, of course, is what do we do with all this data? To my surprise, not a whole lot. So my first task that I took on was to take the data that we are collecting, our water quality data, and put it into a database and create a dashboard for that so that we can view and analyze the trends in the Surfrider Miami water quality. I also soon after learned that Waterkeeper does water quality testing as well. So I started looking at their data along with the state of Florida, Florida Healthy Beaches. And then I decided to start looking at the weather data and to see how the weather is impacting the water quality and pulling that all into a dashboard. What other data can we look at, right? So the data that I'm currently utilizing is, as I mentioned, the Surfrider water quality data, the Waterkeeper data, the Florida Healthy Beaches data, the Department of Environmental Protection spill information. So that information is actually available online to us as well. What else? Open Weather API. There's also several APIs out there for tidal information, current informations, pretty much anything you want is out there and available for you to use via an API. All right. So what does the dashboard look like? This is just an example of the dashboard I'm putting together. This is basically the Surfrider Miami data for 2023. As you can see, Parkview is by far our most contaminated site. Omar can attest to that, yes. So historically, Surfrider Miami tests beach locations. We started testing Biscayne Bay probably about 2 years ago because we had communities come to us and ask us to help figure out what is going on with that water quality. So we're taking that data and being visual people that we are, seeing this is a lot more impactful than just seeing a number on a page. So my goal with this is to show people, wow, look, 2,451 is the average for Parkview. That's really high when you look at anything over 70 is a high number. So you can see this for all of 2023. Biscayne Bay is by far the highest numbers that we have. So I can show you that as well. These are all the locations that Surfrider is currently testing in the Bay. Waterkeeper is also testing different locations. They test a few more in Little River. I don't have them on this chart right now, but I will. We have 6 locations right now. You're going to see 7 on here. We're only doing 1 for Purdy right now. But as you can see, it's almost always high. 51% is high. So that's quite a bit for Biscayne Bay. This is Waterkeeper's data. You can see they test various different locations. Waterkeeper and Surfrider kind of work together. We test on different days, but if we pull all that together, we can start seeing the trends in the data. We can also see the DEP spill data. So you can see on this map where the spills are reported and the information on the spill. That information is readily available on their website as well. It's a little tricky to pull that all together, but it is there and available. So my goal is to get all this information together, analyze the trends, put this out there for FIU or any other students. Jim, I'll give you my data. And I hope you give me yours. And see what we can do with all this. See if we can figure out how to help the Bay and no longer work in silos. Everybody needs to work together to do this and to make something happen. So let's give people visuals and make an impact by getting everybody together and figure it out. And that is all I have. Surfrider Miami, our QR codes. Thank you. Please scan our QR codes if you want to become a member. If you want to help me with water quality testing, they're all right there. Thank you very much. Or see the results, yes. Yep. Thank you.
And I'll also just say, you guys can use the Whova app to put websites, anything else that you want to share. You can put things in the community board. So I'll give you guys a few seconds here to capture these QR codes, but it's not too late. We can all continue to share information after this is over. Okay, so everyone good on the QR codes? Okay. All right, so it's already gone. All right, so next I'm happy to introduce John Mojica, a Senior Research Associate for the National Oceanographic and Atmospheric Administration's Atlantic Oceanographic and Meteorological Laboratory, or NOAA-AOML if you're being brief. All right, thank you so much, John.
Okay, great. Thank you, everyone, for joining me here in this presentation that I'm going to talk about, or well, I call it multi-year high-frequency water quality characterization of Biscayne Bay, Florida, where we basically trying to track the pollution that's coming from the rivers to the reef that are impacting our Biscayne Bay. This is a project that has several collaborators and different, companies, such as DERM, DEP, different NGOs. But here, I'm going to just show you the data that we have been collected since September 2021 by the OCED team here at the AOML NOAA. Because so far there are several studies with different data, but just I'm going to present data that we have been collected for almost 3 years that also have some impact that I'm trying to show you here. In general, this, as we already know, this is our Biscayne Bay. I'm going to get focused on this part, on the North Biscayne Bay, where is the most dense urban core that we have in the area. And here we already have some 20 stations that we split in 2 parts. 10 inshore, 10 offshore that we identify, red and blue, because we're gonna follow the same color pattern. And so far, we already know that our Biscayne Bay is oligotrophic in a good way, but if we doesn't pay attention with the land-based pollution, this can change. And this gonna be a regime of eutrophication and anthropogenic eutrophication if we doesn't modify our behavior, or if we doesn't keep monitoring of the managing. Of course, this can produce some excessive primary production that will be lead decreasing of level of oxygen and well, several other problems for our marine life. Here, just I'm gonna share some couple of photos of our team taking some samples in the bay. You know, here we use some systems. We use an XO just to identify the water column, temperature, conductivity, oxygen. We record the pH. Also, we use some Niskin bottles just to identify or to take samples of water at the surface and the bottom, just to know what is happening in our area. Of course, our field work is lead or depends on the weather and the tides. And why this? Because we go inshore after the peak of high tides in order just to avoid the input from the ocean, and same for on the opposite for offshore, just in order to avoid we go offshore after the lower peak of the tides in order just to avoid the impact of the rivers. So in that way, the direct impact of the rivers. So that way we are sure that the measures that we are taking are just impacting the area by the waters. And here just a couple of photos of our lab where we already followed some NILAG standards and the procedures at AOML. I'm gonna get focused on 4 indicators of eutrophication. The first one, as we already this morning we hear about it, is the phosphorus that, you know, as we already know, is essential for biological nutrients. But you know, too much sometimes is not so good. Same happen with the nitrates, and chlorophyll. That if we have a higher level of those ones, can lead in a lower concentrations of oxygen, that we call it hypoxia, or even now that we call it anoxia, that of course can impact all the marine life in the area. And here just I'm gonna present some statistics, some numbers, trendings. Well, on the left side, we have phosphates. On the right side, the chlorophyll. 2 of the main values that have been changing since this sampling start in 2021. With the cold colors, the purple decreasing, stable green, and increasing the concentrations, red and yellow. And as you can see, sadly, we cannot identify that the concentrations are decreasing, are even increasing in low or high level in those of these areas, in these areas and with these values. Something that we have to keep in mind that is accumulating, and that's gonna lead something like this. Here, of course, red is inshore, blue is offshore, and in the top we have phosphates, on the bottom, nitrates, and we can identify how just in 3 years, the trending is increasing, and we are accumulating these nutrients that, of course, that's gonna represent an impact in our bay. And if we compare with the values or one of the manuscripts from Millet in 2019, of their team, they already identified this concentration as going to have an impact in the area, and they already measure one value of around, well, this 0.04, and today we are getting a value around the double. And they use data from 1996 to 2014, and here is just 3 years from 2021 to 2024, April, and we are increasing these values. Similar is happening with the chlorophyll, where the trendings are higher, of course, inshore than in offshore. But what's happening with the oxygen? Suddenly is changing. The trend is decreasing. So we are creating more consumption, and that's gonna impact our Biscayne Bay. Same if we compare the values with the previous studies, we identify that we are recording almost the double So it's something that we have to keep in mind if we want to know what is happening here. And also another topic that I want to mention is about the temperatures. We already know that 2023 is officially the warmest year on record. This is from in situ satellite data that we have been collected. And of course, all the last decade, we have the highest temperatures have ever recorded. And this is impacting not just the whole world, and of course, our bay. And how is impacting our bay? On the top inshore, on the bottom offshore. This is just the samples that we have been collecting. And well, of course, to get these kind of trends, we need a longer time series. But well, just at least in these 3 years, we can identify some impacts, some direct impacts, such as the event of the heat wave that was recorded in the summer 2023. Here, for example, we can identify highest values in the summer 2023 if we compare with the ones in 2022. That was almost around 2 degrees Fahrenheit higher. And these kind of events can probably happen and come back. And well, I don't know if you feel, but it's so hot right now outside and these days. But it's not just one day. Again, I doesn't plot here the trend because we need a longer periods just to identify if it's true or not. But so my idea or my takeaway here for you is first, we need to identify, or we already identified just with 3 years of data, that the most relevant water quality indicator, in this case, for the anthropogenic eutrophication, is the phosphorus, following close by the chlorophyll. Also, we identified that there is a higher nutrient concentrations inshore, higher than the offshore, if we make that comparison, that we need to keep in mind. We need more proactive management in order just to avoid anthropogenic eutrophication of our bay. And of course, we can identify that the decreasing of the water quality conditions are impacting our area. And of course, we need to include more data, keep our collaborations with several institutions. That's why we invite that everyone share, exchange data, just to make this higher, to identify or characterize what is happening in our place, in our bay. And we recommend that we can have to keep monitoring to know what is happening and how we can tackle down this situation here. Thank you so much.
All right, I would like to now welcome up Ronaldo Garcia, Senior Research Scientist for Florida International University's Institute of Environment. Welcome, Dr. Garcia.
Thank you.
Well, thank you very much. The work we're going to summarize today is actually downstream of all the previous presentations. We are users of data. We're not producers of data. We are producers of simulation results based on a model that has been calibrated and validated. So that's the purpose of our presentation. The title is based on a project that was funded by EPA that lasted for 3 years. And it includes the development of a water quality and hydrodynamics and sediment transport model for the whole bay, south and north part. I want to recognize my colleague, the co-PI of the project, Henry Briceño, which is here as well. So now, so the objectives of the original project was very, very broad and was difficult by the pandemic, because we were in the middle of the pandemic when this project started. So, but the first objective is to develop an operational model. So a model that could be used by anybody interested in the health of the bay. And they would have a model that would predict the water quality of different locations within the bay. And for that, we needed first to implement the model and have the hydrodynamics. So the model needs to generate the hydrodynamics first in order to do any water quality prediction. So the model implementation, calibration, and validation was accomplished measure currents and water quality throughout the bay was necessary and was implemented by FIU because, there are many talks about data, that we have tons of data and things like that, but the data that we require to develop a high frequency model like this is not sometimes the data that you have available. So we needed to develop this kind of information by monitoring and having observations within the bay during the project for 3 years. Then we could apply also the model to determine which locations were going to be monitored, and we did that. And so the final idea is to have a model that would be available to anybody interested. We have some details of the numerical model. The model is based on a flexible mesh model that is based on a triangular grid. So each of these triangles that you see here is one computational unit. At each of these locations, the model generates the velocity, depth, and the water quality parameters if you are running that component as well. The first implementation that was accomplished was based on the bathymetric data available from NOAA, and we used that public information. It's a 0.5 to 3 meter resolution for the whole bay that was updated in 2019. And this is just an example of the model extent. It goes from the south to the north bay as well. It has different resolution. The model can have different resolutions at different locations. So what you see here is the model extent on the first, that polygon there. This is the bathymetric data that we obtained from NOAA, and this is the final mesh of the model that is implemented in BBOM. This is the detail. As you can see here, the model is not not a fixed mesh. You can modify the mesh if you want it for different purposes, but you can refine the mesh at different locations to obtain better resolution. So the final implementation used also data from NOAA for the tides and wind velocity from Virginia Key Station. And a large number of databases that we consulted. One of them was the South Florida Water Management District stations, where we had elevation data, so depth along certain time, and also salinity. So the first approach was to calibrate the model using salinity, which was the parameter that had more data available. So we used salinity at all of these stations and also water elevation that could represent the model simulation for a year, and then compare the model results with the observations to see how good or bad it was performing. So we did that with a variable mesh, and then we had a lot of time required to enter the boundary conditions and have the proper boundary conditions. We had boundary conditions that include the tidals at all inlets, from safety valve down to the very end, and also inflow from the canals. But the main data that we were missing, and we are still missing, by the way, is the inflow from the inland groundwater. So we couldn't calibrate the model until we had the data and assumed data from the groundwater into the bay. So after we did that assumption, we could calibrate the model. And I summarize here some of the results. What you see here in the left images is the comparison of the water surface elevation obtained by the model and the observations at each of the stations. I'm showing here a few stations, but we had 40 of them. And on the right is the salinity variation along a full year of simulation. So these are all validated and calibrated data. And so at the end of this process, we were satisfied with the model results to make predictions for future applications. So just to finalize, I have a couple of slides here. This is some of the statistics of the validation period. And what you see here of this, each of these maps is a snapshot of the salinity distribution at different times during the year. And think it's better to see here the dynamics. So what you see here with colors is the salinity throughout the South Bay, only the south part, and throughout, I think, a period of day 150 to, so 30 days. So the model produces every 15 minutes a snapshot of all the distribution velocities and salinity in this case that you can see and make predictions based on the inflows that you have established. So, well, some final comments. I don't have too much time to go over those, but I think the takeaway from this is that we have already a validated model that can be applied to study different management scenarios within the Bay. We're very happy to see that the model is able to predict the depth of flow everywhere within the Bay and also the velocities and the salinity. We are in the process of extending the model. Actually, we have a new funding from EPA to extend this model to account for plastics or microplastics distribution and transport. This is our present focus, and that will be an extension of the BBOM model to the whole Biscayne Bay. Thank you very much.
All right, we have time for some questions. I want to do a quick round of applause for all of our presenters really quick. All right, everybody up front. Okay, question the first.
Well, okay. Well, the first one's a real quick one. That that animation or GIF you had on there, was that tides coming in and out? That one animation that was high and low tide, just going pulsing. And then second, Dr. Forkerin made the comment about the cost of buoys, and Marilyn asked about what these cost. And I like the fact that he was talking about there's lower cost ones available, and could the the public or groups fund them and get them placed somehow. I wonder if that's possible. And Scott in our group looks into that stuff and has been looking at buoy stuff as well.
Yeah, so the Institute of Environment at FIU has been putting buoys out, not the oceanographic buoys, but bay buoys and river buoys, and quite a number of them have now been sponsored by private groups. And in fact, we've put a couple of people's logos on buoys out in the bay. So we'll do it, and I imagine others will too.
DNR.
There is a bias towards how far I have to walk in these things.
This is a question for the your modeling. What oceanic model are you using to initialize oceanic circulation into and out of the bay?
You mean the incoming?
Yes.
No, we don't. We're not using. We have a boundary condition in all of the inflows. The boundary condition is the tidal elevation data from Virginia Key. So we are not using an ocean model. The model ends on those boundaries, and what the model does is take the tidal elevation, and based on the solution of the equations inside, it determines the currents or velocities everywhere.
I'm wondering if wind forcing and other dynamics of the Gulf Stream would be influencing. If you would see anomalous circulations and patterns because of the dynamics of the Gulf.
Well, the internal dynamics of the wind, it's determined by the wind forcing within the bay. But we are not taking into account the general currents that can be affected. So what we have observed is that the effect of the currents is very rapidly diminished once you enter the bay, because there is for instance, in the safety valves, it's extremely shallow. So all of the currents that you may, that's our experience at least, is that they tend to attenuate very quickly, and the most of the inflows come, for the most part, perpendicular to those inflows there. But I mean, they could be in future incorporated another way to generate those boundary conditions from other model.
Coast Office Coast Watch office is
Hmm.
looking to, for groups like this to do high resolution modeling in the next few years. And we're looking for collaborators for projects to give you higher resolution oceanic circulation modeling along the coast to help you with boundary conditions. Yeah, sure. Yeah.
Yeah. Mhm.
Hooray, we're making connections. All right, I'm going to trek to the back. Do I have any questions back here for any of our four speakers? Huh? Okay. Here you go.
This question is directed towards the data transparency and accessibility talk. Well, first, I'm a big supporter of it, so my criticisms come from that place. I'm wondering what sort of education would be given to end users on how to use this data, because it's a very powerful tool to have lots of data, but you also have to understand where it's coming from. And you may have data points that are the same parameter, same area, but the methods were different. And so someone coming in might not understand that if they're not from that community. So how would you assist people in analyzing this type of data?
There you are.
So this problem goes way deeper than just end users. Right now, we're having a difficult time because we've got high-end computer science database guys working on this, and they don't really understand what we're trying to get out of the data. So our first problem is translating what we as data end users want to see from their presentations of the data that they're harvesting. But right now, the entire program is this incredibly like SQL like query system, and it's very difficult. The real key is going to be the design of the user interface. So we're collecting the data that one would need to in order to understand can you really marry two data sets together with all the metadata? But the trick over the next couple of years is going to be developing that way to have almost an expert system to look to see if the two things that you want to do really are compatible. So we understand that collecting the data is the easy part. It really is the easy part, and the real work to be done is working with computer scientists to figure out that translation part.
All right, I believe we have time for one more question if anybody has any. If you think of one later, please seek out our speakers when I have these conversations. All right, guys, the next session starts promptly at 2:30. In this room, we have a presentation on the state's preemption of plastic bans and then a workshop on marine debris. So you're welcome to stay and hang out, go get some coffee, or make your way to your next session. Thank you all so much.